Good morning, everybody. So we're talking about quadratics. I might have to break this into a couple of videos, so bear with me. So quadratics, they can come in two forms. You can have the standard form, which is the top, or you can have the vertex form, which is the bottom. There's a couple of things of note. These a's that are listed are the same values. This h and this k represent the x-coordinate and the y-coordinate of the vertex. The vertex is hidden in here, and there are some formulas that we need to learn for that. A real quick comment though. You see this negative that's on this h. Remember, when we're dealing with transformations, that means this is the opposite direction. So when you pull your h out, it comes out as a positive. If it's in this form and it reads positive h, you'll pull it out as a negative, okay? Now, making a cameo appearance, of course, is Murphy. Say hello, Murphy. Good dog. All right. Your graphs, based on the discriminant, so if your discriminant, which is b squared minus 4ac, and that's actually part of the quadratic, so I'm going to take a moment and I'm going to write the quadratic down. And remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. This piece in here is referred to as your discriminant. If your discriminant is greater than 0, you see it taking a square root. If it's greater than 0, what you have is a parabola that crosses the x-axis in two spots. You have two x-intercepts. One x-intercept here, the other x-intercept here. Now, a couple other pieces of information. The vertex is the bottom point on an opening up parabola, and the vertex would be the top point on a parabola that opens down, okay? There's a thing called the axis of symmetry, and depending on the form, the formula either reads negative b over 2a, so if it's in standard form, you pull out the opposite value of the b, and then you divide that by 2 over a, or if you're in the vertex form, it's x is equal to h. Now again, remember that over here it's written as a negative h, so when it comes out, it is the opposite, okay? And the axis of symmetry splits the parabola into two equal halves. Now, this is a little bit misleading because this is actually the y-axis, and so the axis of symmetry is supposed to be drawn as a dotted line because it's not technically part of the graph. It's just this line that mirrors left and mirrors right. Okay. Now, what happens if your discriminant equals 0? You have what's referred to as a double root, or a root that has multiplicity 2. The x-intercept and the vertex end up actually being the same thing, and the parabola draws down, it bops, and then it pushes back up. So it bops on the x-axis, just touches it once, and then it takes off. Your axis of symmetry again splits it in half. This distance, even though my hand drawing is flawed, if I take a y value, the distance over to each of these x values should be equal. So this distance and this distance should match up. Now, what happens if your discriminant is negative? Well, then your parabola looks like it's floating in the air. You end up with two complex roots. Your b squared minus 4ac is going to end up being negative, and when you take the square root of a negative, you're off into the complex plane. Okay. Now, if your a is negative, I made the comment, I think, that it turns the graph over. So if your standard form has a negative ax squared, or a vertex form has a negative a, they're upside down. This is if there's two real roots, this is if there's one real root, and this is if there's two complex roots, okay? All right. Now, finding the axis of symmetry and finding the vertex and domain and range. So let's begin in standard form. So if you have f of x is equal to ax squared plus bx plus c. Well, the first thing you find is referred to as the axis of symmetry, which is negative b over 2a. So if our equation is the following, f of x is is x squared minus 3x plus 4. Well, our axis of symmetry, now you see our b is this value right here. Pull it out as its opposite. So it's 3 over 2, and the a is the coefficient of the x squared. So I end up with 3/2 as the, x equals 3/2 is the axis of symmetry. Nice thing about knowing that is that tells us the x-coordinate of our vertex. So that's 3 over 2. Now, I had written down over here, let me turn back the page, that the equation or the formula to be able to determine the values of the vertex in the standard form are negative b over 2a, and then you take this value and you plug it into the function. So we're going to plug this into the function. We're going to take the 3 over 2, and we're going to put it here and here. So we're going to have 3 over 2 squared. Oops, I put a plus. It's supposed to be a minus. I can sneak it in that way. 3 over 2, and then plus the 4. Well, this is going to be 9/4. This is going to be 9/2. All right, and if you work that through, I'll just work it through. 9/4 minus 18/4. And getting the common denominator, you have plus 16/4. So this is going to be 7/4 when it's done. Okay. All right. So this is the vertex. Now, very quickly, and what's nice about it, you can take that information and generate the vertex form of the parabola. You know the a matches, because it's in the formula it says a and a. So here's our a. It goes a x minus h squared plus k, and that's your function. Okay, so these two a's match, and later I'll show you how they end up matching and how you can actually work it through without having to determine your vertex by hand. You can actually manipulate the equation to get one to the other. Okay, so there's your 1. Okay, so the 1 comes from right here, and then it's x minus h squared. So I want x. Now, here it's 3 over 2. Our x-coordinate is 3 over 2. We want our parabola to actually shift over to the right. And so what we do is we subtract the 3 over 2. And then it's plus k plus 7 over 4. So I'm going to write plus 7 over 4. Before I go any farther, I'm just going to do one thing. I'm going to multiply this out and show you that you can go from this form here to this form here. So it's going to look like this. 1 times x minus 3 over 2, x minus 3 over 2, plus 7 over 4. So we've got x squared minus 3 over 2x minus 3 over 2x. That's plus 9 over 4 plus 7 over 4. X squared minus 6 over 2x plus 16 over 4. Well, that's x squared minus 3x plus 4. All right, we're stopping there.